Welcome to Spring LIB.
This incline here, we're going to say that this is some angle theta, the angle of the incline, and then we have a bowling ball traveling downwards. Now here, the actual only force, let's draw a free body diagram. Only force would be going straight down, which would be the force due to gravity, and then perpendicular to the surface of the incline, force normal. And so essentially, when we're dealing with this, we'll say that the sum of forces in the x direction would be equal to the mass times the acceleration in the x direction, which in this case would be equaling the mass times gx. So essentially, this would be equaling the mass times the x component of the acceleration. Let's cancel out the mass, and so the acceleration in the x direction, we're choosing our Cartesian axes to be, of course, essentially convenient for us. And so essentially our acceleration in the x direction would be equaling the magnitude of the acceleration of gravity on Earth's surface, 9.8 meters per second squared, multiplied by sine of the angle of the incline theta. And so this would be our answer for the acceleration due to gravity. Again, this is we're going to assume that this is a frictionless line. We would have to account for friction, but the method is the exact same. And so with work, in terms of work, we know that work would be the change in the kinetic energy. Now here, the potential energy at the highest point, let's just say that this was the highest point, or the highest point of the center of mass. And let's just say that this distance here is considered h. This would be equaling the mass times the acceleration due to gravity times h, the height of the incline. The length of the incline would not be taken into account, but for work, matter the path that you're traveling. It only matters your initial point and your final point. So it's not as if the length of the incline actually matters. It's only the height of the incline that matters the most, because this would be our true displacement in the x direction. So this would be equal to the work, rather the y direction. So this would be the work done by gravity. And again, the work done by gravity would end on your initial and final position. So if your final position is at the end of this incline, the work done by gravity is simply equal to h, the height of the incline, or essentially the height of the center of mass of the ball. That is the end of the solution. Thank you for watching.